So your question is what are the cost drivers in terms of hardware or software? Both? For our cost. Okay, so I mean, just the bill of materials is obviously something that we have to consider. And I mean, there's this really interesting thing that I discovered. I don't have a background in manufacturing. That's why I have people that do that. But what I was kind of surprised when I first got into 3D printing as manufacturing business is the massive price difference between just buying a couple of units and buying at volume. So like 10,000 unit volume, 10,000 is kind of like the magic number, it seems. So, you know, it's one of the interesting things is just kind of like building up volumetric production techniques and being able to do that while staying flexible in terms of materials and in terms of low upfront tooling costs so that we can make changes to the designs as we go along. So on the hardware side, I think that's one of the biggest elements. And then, of course, labor is another element. We're built, we're design and built everything here in San Francisco just down the street at Tech Shop. That's actually been a benefit for us because it means our R&D is way, way faster than anyone else. We have access to $1 million of equipment for $100 a month, essentially. That's pretty cool. So big shout out to Tech Shop for those of you who haven't been there. I'd say the last cost driver is going to be on the software side. You know, 3D printers, like Emmett was saying, as well, like they need to be easy to use. And you know, the stuff that Microsoft's doing is really valuable, but it's only the first step in a very long tool chain.
So for us, it's two things. It's the mechanical parts of the motion control, but also the motion control electronics. So like the other mill folks, we use the Tiny G, but because we're doing pick and place and you need to have, we estimate about 50 micron precision, we also do servo drives, and that adds price. Another big addition is just make sure that you have, on the mechanical side, motion components that are very precise and repeatable.
Yeah, mostly for us, it's the same. You know, it's component cost. But actually, I just wanted to say, if anyone comes up with better motors than Hayden Kirk that are less expensive, that would be significant. For us, it's the most significant part of what we do. Just the cost of high precision motors. I mean, they are amazing, the ones that they make, but they're really the only game in town. So there's a little bit of room there if anyone wants to work on that. Yeah, okay.
Okay, I actually have two questions, and I think they kind of fill the breadth of what other people are thinking, but maybe first to Mr. Larson, the cubes that you passed around in the beginning, everybody touched on currently 3D printing being quite a slow technology. Could you give us an idea of how slow is slow? What can we expect from the output? A time to maybe produce one of those cubes as an artifact, for example. And then the second question, kind of gathering in the ease of use, the functionality that it seems that everybody is trying to attack at the moment as well. What is the current process from working with Autodesk or Inventor at a current CAD file into converting that into a final output? In terms of taking that through a workflow, and what are some of the hurdles that are trying to be diminished at this point?
Let's see. The question was, what's the workflow like?
First question, how slow is slow?
And how slow is slow? And slow is actually becoming quite subjective because slow 2 years ago seemed to be pretty fast the year before. So like right now, on a printer like that, with the right open source firmware, you can print at 120 millimeters a second, which is kind of that's kind of like the magic fast speed. I don't know how fast does yours go. Like, we'll let you answer that. Okay, so his is even faster. So it's, like I said, it's very subjective. See, that's why I wanted to point that out. So and like right now, I think it's printing at maybe 80 millimeters a second. So like to print one of those cubes is depending on. Then this relates to your next question about process. You draw your thing in a CAD program, and in my case, I use SolidWorks, but a lot of people use Autodesk. The Tech Shop actually has an Autodesk master license, and they do training there too, so you can learn Autodesk. Once you've drawn it, you bring it into another program, which is some kind of a CAM package that turns it into a file that can be printed. And there's a number of different ones. The one that MakerBot has their own, it's called MakerWare, which it hasn't always had their own, and they have features in there that the open source packages don't have. But then the open source packages have features that aren't in MakerWare. So, but Replicator G is the one that I've been using, and you bring it in there. You bring an STL file in. Somebody else brought up this whole thing about interoperability and what kind of a file do you bring in, and and another problem too is once you bring it into one of these programs, a round hole is not a round hole. It's really a whole bunch of polygons. So it's round really isn't round. So and then by the time you print it out, it's really not round. So like if you want to print a round hole and shove a round peg into it, it takes tons of trial and error to make the peg fit in the hole perfectly. But then you render it, you put it on there, and then you run that file that it generated, and it goes. So depending on how much you fill the inside, the more infill you get, the slower it goes. The less infill you get, the less structural integrity you have, and the less capable it is. So like one of those cubes, I think the little cube that I'm printing there, which is about half the size of a regular cube, takes about 30 minutes to print. And so I've printed it twice since we've been here, and we'll have 2 by the time that's done. So.
Like maybe say something. Yeah, so take a look at some of the prints over at the table. There's a Leaning Tower of Pisa. That took about 16 hours to print. And as Ted was saying as well, like it's a function of a number of different parts, like the resolution you're printing at. If you're printing at the higher resolution, it takes more time. The more material you use, obviously, it takes more time. The more important the print is for you to finish, it takes more time. That's a psychological thing, but yeah. But I hope that helps. What was the second part of your question again? Right, okay, yeah. So I think Ted covered that pretty well. I mean, it's basically just what we're seeing is that it's getting better and better. And I actually don't think we're that many months away from having click-to-print integration. Thanks to Emmett. Yay! So that's really important. But I mean, we are still months away, and that's a long time in this industry. Yeah.
So I think in terms of the workflow perspective, I think Danielle and myself are in a position where we get to really write our own workflow between your design and the manufacturing process. I think both of us have elected to take the drag and drop approach from you export it from whatever CAD file you like, drag and drop it into our software. And then I think one of the luxuries that we have with our machines is the computer vision helps to make the setup a lot easier. Do you want to talk more about your setup? Or?
No.
All right.
Okay. Can you talk a little bit about 3D printing in the classroom for education, and also in particular, potentially for people who have visual impairment or learning disabilities?
I would love to talk about that. All right, so 3D printing in the classroom is one of the really interesting sort of areas for me. Oh, so repeat the question. Talking about 3D printing in the classroom, and also what about people, visually impaired or with learning disabilities? That was your question, more or less? Yeah. So first of all, we're developing K-12 curriculum now, together with partners here in the Bay Area. We've also worked with there are a bunch of high schools and universities here in the Bay Area that have our printer and are actively printing as part of the classroom experience. We're also working with San Francisco Public Library. They've got one of our printers, and a whole bunch of other maker and hacker spaces. What I think is hard for them right now is usually they only have 1 or 2 3D printers and like 30 students. So there's only so much stuff that you can do in terms of 3D printing for each person, customized prints. But I think that's changing. There's a great guy called Brooke Drum who runs PrinterBot a couple of miles north of here, and they're working on kind of like making 3D printers cheaper as well. So you can get a okay functioning 3D printer for like $300. It won't do everything that one of our printers can do, but it works, and it's a good way to learn about 3D printing. I do think that the other element that I'm really fascinated about in terms of classroom teaching is using 3D printing as a tool, not like learning about 3D printing itself, but just having 3D prints as active learning aids in the classroom. So being able to, 3D print the Statue of Liberty, or 3D print, molecular structures or mathematical concepts, geometrics, like there's a whole bunch of stuff, everything from history class to biology, that can really be benefited by more hands-on sort of education, trial and error, and so on. We did a project with Cal Academy of Sciences where the students 3D printed fish that they invented, and they came up with their own. For some reason, they were all sharktopuses. Yeah. So it's sort of varied combinations of. I think one of them had like a narwhal spear as well on his head. It was pretty awesome. Moving on to like visually impaired people. I was actually asked this question a couple of months ago by a woman that worked for visually impaired people, and she asked me, "Can you 3D print pictures?" Because all of the textbooks at the moment have software, like there's software out there to translate text, but not images. And so many of the textbooks in today's schools use images a lot, like it's part of the learning. And so, yes, you can. I don't know of any software that does that automatically, though. So, having that come out would be pretty cool. Do you have stuff?
I love that. I mean, the other thing I would say is that, as an engineer, right, when there's a lot of people that I think are daunted by engineering and maybe don't consider it when they're in high school, but I think a lot of that could be dissuaded if you can really get a chance to go through the whole process. I think that there's a fantastic opportunity to be able to say like, hey, you can actually design something and create it. And that gives you, so much. Like when you're in math class and the high schoolers are saying, well, okay, all this trigonometry stuff, that's great, but what could this possibly be useful for? And you can say, haha, that is how you make this thing. You wanted to make these two gears mesh, this is what you need. And you can see how when you get it right, you can build this part and it does what you expect. And I think that closing the loop on that could be a really powerful way to sort of to make it more accessible and more interesting for people to actually learn all these critical math and science skills.
So this is a sort of question that gets me excited as well. So there are two things there, picking up on what Emmett was saying as well. When we work with kids, we're seeing a shift in the mindset. And what it's essentially about is just rapid prototyping, getting the fact that it's okay to fail. Because you're moving from a sort of ready. Mark Hatch, the CEO of TechShop, he talks about this a lot. He's just come out with a new book called the Maker and Manifesto. Shameless plug. And what he's done is he talks about this idea of ready, aim, fire versus ready, fire, aim. And rapid prototyping is all about the latter. And what I'm starting to see with some of the kids that we've been working with for a longer time is their confidence levels in themselves is increasing because they're starting to realize that it's okay to fail. It's okay to get it wrong. And then you analyze that and then you improve upon it. And it's super, super powerful. And I think that's, the problem with the school system right now is that you lose kids every year. Like mathematics is a great example. If you don't understand the concepts in year 1 of mathematics, you're definitely not going to understand the concepts in year 2. And so every year you're losing some of the kids. With more hands-on education, I think, and the Khan Academy is a really great example of this as well, by the way, on the online side. Just having that kind of like modular education that builds on your previous experiences and building more of a portfolio than anything else, I think could be really, really powerful. And I think, you guys are part of this as well. Just having, what happened to the wood shop in schools, right? Where is that anymore? Like, I would love to see new desktop machines in schools to enable that to happen. And that's everything from milling machines to electronics to 3D printers. Yay.
Next question. Or you guys finish? Yeah, next question's here. Those are nice, and that's how everybody who wants to disrupt something says, but how do you actually create a marketplace so you can do that? Because you've got the makers, you've got people who are gonna buy the consumables. Where are the customers, and what's the total addressable market?
We can talk about that. So are you asking what are the customers like that will buy the machines? Or
That's the innovators. I'm talking about the actual retailers.
oh, okay, so who's buying your parts?
We know who's buying them now. Who's going to absorb at the end of the day and buy your actual stuff that you guys make nicely? Where's the Zazzle for this part?
Zazzle. Oh, like Etsy?
Yeah. No, like Zazzle.
I don't know what Zazzle is.
Where people come with great designs,
Uh-huh.
and then other people buy them or mod them, print them out, and the designers who made the first ones still get paid yearly.
Oh.
Because you've got Kickstarter, which is like basically
Mhm.
like Apple did, and you've got like a couple other things around there, a lot of people waving their hand. But like, where is the full market that then lets all these people invest in these PRR machines,
Uh-huh.
design stuff, actually be able to pay long-term bills with that?
Yeah, so I think what he's asking is, where's the marketplace for the people who design the files to sell them to the people who will get them and print them? Ish. I think that that doesn't really exist yet. And maybe it's because I go back to this thing about like, okay, most people follow a recipe to do things. So there's like a certain percent of people who will just always follow a recipe. And then there's a smaller percentage of people, or a smaller portion of people, who will modify a recipe that they've been following for a while. And then there's the very small, way smaller amount of people who will invent a new way to bake bread. And I think that like the CAD portion of like designing a thing from scratch out of nowhere is a really small portion of people, and it's mostly people, will mod things. Most people will do like buy a thing that already exists. And so I think that marketplace doesn't exist yet because there just aren't very many people in those two categories of I'm inventing bread and I'm modifying a recipe of someone else's. And I think to get that to happen, we just have to educate more people. We have to expose more people to the tools, both software and hardware, make them see that it's possible, and then there will be enough economic reason for there to be a marketplace, is my opinion. Sure.
So I think one way that these technologies are already very much being consumed by a huge number of people is in the sense of their use in product development labs. So you see any companies like with a 3D printing case, from Ford to Boeing to a lot of smaller companies as well, that they'll use the 3D printing technology to go and iterate through designs and come up with something that's going to be saleable. Then they'll go and make the molds and sell a boatload of them to customers that way. So that's, I think, for me right now, the most impactful and compelling way that these technologies are being used and being exposed to folks. But I think down the road, you'll see more and more people capable of making their own stuff.
All right, I'll see if I can give you some numbers. How's that? So you asked about total addressable market. The additive manufacturing market has been sort of guesstimated, and I use that word, by the Woolers report, which is the industry sort of report, at around $2.2 billion this year, raising to, and here's where all the reports start varying as they get increasingly optimistic or pessimistic. But if you go out to a couple of years from now, so say 2015, then you're at about somewhere between 6 and 7 billion. And then if you go out to 2020, it's like somewhere between 8 and 11 billion dollars. Now that is for additive manufacturing as a whole. And of course, desktop 3D printing is a small part of that. Right now, the numbers I have in my mind is just for the jewelry market. Jewelry is really big on Shapeways and Pinocchio because it's such an easy starting point for designers and mass consumers to get on board. I believe it was about $14 million this year, and then rising to, I think, somewhere around $40 million by 2015. So, I mean, the compound annual growth rate of the market right now is just insane. Well, just to put it in context, if you go back just a couple of years, there were less than 5, so back to, I have to be careful here, about 2008, I believe, there were about 5,000 desktop 3D printers in the US. At this point, there's close to probably 50,000. And you know, we went from producing, you know, 1 machine a month last year when we started, and we're doing 20 a week at the moment. MakerBot's doing 700 a week. You know, it's crazy right now. It's going pretty crazy. And by the way, we're looking for investors. So yeah, let us know.
Okay, let's go for one more question.
This is a question for Emmett, I guess, with Microsoft. You talked about how you wanted to make 3D printing analogous to 2D printing within just do a file print. And you also talked a little bit about the scanning technology. Now, is the idea of the scans similar to optical character recognition in 2D printing? You do a optical object recognition, and then be able to print based on that. Is that the vision that you're working with?
Okay, so I believe I got your question was that while we're working to make 3D printing like 2D printing, what is 3D scanning, and kind of what methods are we looking at there? So first off, there's a lot of people working on 3D scanning, and a surprising number of quite different technologies, actually. Certainly we're working on some at Microsoft. I mean, already there's a lot of people using Kinects to do 3D scanning of, like, actually, I got my whole self scanned at Maker Faire a couple of weeks ago and printed myself out. I mean, that's pretty fun. So a lot of this stuff already exists. 123D Catch is another great example where you can basically, you know, instead of actually having a sensor that senses depth, you can use a pure two-dimensional sensor, just your camera, and an incredible amount of math to create a full three-dimensional object that way. It's interesting that you bring up OCR, because that's actually kind of a whole nother method, right? Because there, you're not really finding the shape of the character directly. You're saying, oh, I sort of know a few characters, and I'm going to find the one that's closest. And that's another thing that people are working on. I know especially where people are looking at face scanning specifically, and it can be difficult to get the resolution necessary to really make a nice face. But if you can kind of parameterize the array of human faces with some like fewer number of variables and then kind of fit them based on your data, you can do a better job. There's definitely people working on that as well. So I think I would imagine that the space of 3D scanning is still kind of just starting. There's going to be a huge number of technologies there.
Cool. Okay, I want to finally thank my speakers again. I really appreciate you guys coming down and flying down for us tonight. Thank you very much.